Okay, so now we're going to move to section 2.2, and we're going to formally talk about integers. So let's start our discussion here with something we've already talked about, whole numbers. So if you recall, whole numbers were the numbers that started at 0 and counted forward 1, 2, 3, 4, so on and so forth, all the way up to as high as we want to count. These are our whole numbers. So we're counting in from left to right, and we're going to a large number. Ultimately, we're going to head towards an idea that we call infinity here. But infinity is not a number. It's just an idea. But so we get a really big integer, and we can go to any number of integers that we want, or whole numbers that we want in this direction. Well, we can also count in the other direction. We could go 0, and then we can count to the left this way. And since we're going to the left, we need to indicate that we're moving this way. We'll put a negative sign in front of the number. So that's 1 in the left direction, minus 2 in the left direction, minus 3. So we can count this way to the left, and we can go on to negative infinity in the same way. So we can count both left and right of 0. And when we do that, we call that set. We call those integers. So integers are whole numbers with negative numbers. We call these negative numbers included. That's what integers are. So we could do some operations on these, mathematical type operations. Just like we did with our whole numbers. We can compare them. We can compare two integers. And this is the operator that let's use some comparison operators. We have less than, we'd have greater than, and equal. Well, equal is something we've used a lot. So we have a symbol to represent less than. It looks like this. The symbol for greater than, the bigger opening is to the left, greater than, and equal. So less than, when you're saying a number is less than another number, you're really saying it is left. And if it's greater, one number is greater than another number, that means that it is right of that number. And if it's equal, it's the same point. For example, we might say minus 4 is less than 0. That makes sense. Here, let me draw a number line. So here, I've slapped in a number line up above here, and you can see that I'm kind of like centrally located 0 here in the middle, and the numbers to the right of 0 are positive numbers. And we don't usually put the positive sign in front of the numbers. We usually leave it off. It's implied that that positive sign is there. We leave it off, but we do put the negative sign on numbers, the numbers that are to the left, as we count up to infinity on the left side of 0. So if we look at minus 4 here is to the left of 0. So 4 is less than 0. That's how we're going to do that. We could continue here. we could say like 8 is less than 10. I don't have 10 on the number line. 10 would be over here. But 8 is less than 10. 7 is greater than minus 7. 7 is here. It's greater than minus 7. Let's go. Minus 2 is less than minus 1. So minus 2 is to the left, even though 2, positive 2, is greater than 1. So positive 2 is greater than 1. It's to the right of 1. Minus 2 is less than 1. Okay? And so we could say 4 equals 4. A little trivial, but we could still say it. And that, oddly enough, is essentially the main topics covered in section 2.2.